This presentation introduces you to one of the fundamental principles of drafting, and that is the use of orthographic projection to convey a full understanding of the object to be manufactured. As a result of this lesson, students will be able to identify and name the available orthographic views, select from those views the ones most commonly required, and understand the meaning of the terms height, width and depth, and where they apply to the object being drawn. Pictorial views in many styles can be made to show the general appearance of an object, but an exact description of the shape requires properly arranged views made from certain selected lines of sight. This drawing is in 3D, the way all actual objects are viewed. This type of drawing is very hard to dimension, costly in terms of time and money, and does not give a comprehensive understanding of what the object looks like when viewed from other directions. When an object is drawn in 2D, more than one view is usually needed to give a complete description of the shape, in this case the top, front and right side views. Orthographic projection creates views of an object taken at right angles to that object and arranged in specific relative positions on the drawing. They not only identify all aspects of the shape of the object, they permit the dimensioning in the three principal directions: width, height and depth. Lines of sight must always be perpendicular to the surfaces of the object. This is the line of sight to the front view. This is the line of sight to the right view. And this is the line of sight to the top view. Normal surfaces are surfaces of an object that are 90 degrees vertical or horizontal to each other. When a surface of an object is parallel to the plane of projection, or a normal plane, the surface will appear in its true size and shape on that plane. There are at least 6 different views available in orthographic projection. They are front, rear, top, bottom, right and left. To illustrate how orthographic projection is used, let's consider a cube. There are 6 sides on a die. That die can be unfolded and placed on a flat drawing surface. It then shows the 6 possible views in orthographic projection. The great majority of objects do not require all 6 views in order to provide a complete understanding of the form of the object. As each view takes time to produce, economies can be achieved by creating only the minimum number of views necessary. For many objects, 1, 2 or 3 views are usually enough. This object can be fully described by 3 views, and the most commonly used views are the front, the right and the top views, although sometimes the left side view is more informative and will be substituted for the right. The front view is usually the one that contains the most detail and the fewest hidden lines. This view contains height and width dimensions. The top view is located immediately above the front view and contains width and depth dimensions. And the right side view is placed directly to the right of the front view and shows height and depth dimensions. These 3 views are known as the principal views and are the views usually required to describe a 3D object in 2 dimensions. Some objects, due to symmetry or simplicity, may require fewer than 3 views. Examples of objects that require only 2 views are cones and cylinders. A sphere, also by virtue of its simplicity and symmetry, may be illustrated using just one view. So too can very thin items like this gasket, the thickness of which can be defined in a text note. In fact, if a drafter were to use more views in the workplace for such objects, they may find themselves invited to the office of the drafting manager for an informative few minutes. The characteristic of many new drafters is that they include too much information, or else too little. An employer will soon learn to value someone who can provide the optimum information in the minimum number of views laid out on the paper in an easily readable form. A good way to illustrate the concepts of orthographic projection is the glass box method. An object is placed inside the glass box, and views are created by drawing perpendiculars, called projection lines, from all points on the edge of the object to the glass plane. First to the front face, next to the top face, and then to the right side face. You now have true projections of each of those three faces on the surfaces of the glass box. Further projection lines are now drawn to connect the three views along the surface of the box. If the glass box is then unfolded, the glass panes represent the three principal views of the original object. With this method of viewing the object, it should be noted that the viewer is always on the outside of the box looking in. This type of projection is referred to as third angle projection and is the method of drafting used in North America. There is another method known as first angle projection, which is used in Europe and the Far East and not covered on this course. The ability to visualize the different views is very important to drafters, and it takes practice. With this object, the edge CD is seen in the front view as a vertical line, in the right side view also as a vertical line, but on the top view the line is seen only as a point. A plane surface is represented by three or more points. Points 1, 2, 3, 4, 5 and 6 enclose the top surface of this shape. On the front view, the top surface is represented by a horizontal line. On the right side view, top surface is also represented by a horizontal line. It is only on the top view that the surface is shown in its true shape and size. If a normal plane is intersected by a line in two views, the result will be seen as an offset plane in the third view. This is a good time to emphasize the need for that third view, because two views can be correct for more than one object. This presentation gives you just an introduction into the orthographic method of laying out drawing information. In discussions with your instructor and your fellow students, you should now be able to identify 6 possible views used in orthographic projection, identify the 3 principal views in orthographic projection, and identify the correct locations for height, width and depth in those principal views.